So guys, today's video is about the synthetic polymers. In the previous videos we have done the structures of proteins and the structures of the structure of DNA, and that those polymers were natural polymers. Now let us take a look at synthetic polymers. See, synthetic polymers can be divided into two major classes. One of them is condensation polymers and the other one addition polymers. We will take a look into the detail of each of them one by one. First, start with condensation polymers. See, first of all, what are condensation polymers? I'll repeat the basic again, that what are polymers. See, these are the long chains formed by the linking of many small molecules. Polymers are the long chains formed by the linking of many small molecules. Now, those small molecules which make up the polymers, those small molecules are called monomers, and the long chains are called the polymers. And the reaction which takes place between monomers to form a polymer, that reaction is called polymerization. So right now we are talking about condensation polymers. Condensation polymers are the polymers which are formed by condensation reactions. And as you already know what a condensation reaction is, it is a reaction in which a small molecule is produced as a byproduct. For example, water, for example, HCl. Either of these could be produced. Okay, now condensation polymers, we will study these condensation polymers under two subheadings. One of them are polyesters and the other ones are polyamides. See, these names polyesters and polyamides are due to the types of bonds present between the monomers. Like when there is a polymerization reaction taking place and monomers are linking up with each other to form a polymer, that linkage type between the monomers determines the name of the polymer. See, if the linkage between them is the ester linkage, the function group of esters is holding the monomers together, that means the polymer is classified as a polyester. Similarly, if the linkage between the monomers is amide linkage, then the polymer is classified as a polyamide, because that type of linkage is being repeated over and over again. Poly means many. Okay, now polyesters, in which ester linkage is repeated several times. Now, one of them One example of a polyester is terylene. Now, terylene is made by the reaction of two different monomers. One of them is 1,4-benzene dioic acid, 1,4-benzene dicarboxylic acid, and the other one is 1,2-ethane diol. These are the two different monomers which keep on linking together to form terylene, which is a polymer, which is a polyester. And this reaction requires specific conditions to take place. And the conditions required for this reaction is a temperature of 280 degrees C and a catalyst antimony 3 oxide. Antimony is a metal, and antimony 3 oxide, see Sb2O3, this is the formula of antimony 3 oxide. It is used as a catalyst. So now let us take a look at the reaction that takes place during this. See, this is benzene 1,4-dioic acid. And this is ethane 1,2-diol. They react with each other at a temperature of 280 degrees C and a catalyst of antimony 3 oxide. Now this is a polymerization reaction. That means there are many molecules of ethane 1,2-diol and there are going to be many molecules of benzene 1,4-dioic acid. Let us say there are n number of molecules of this diol and n number of molecules of this dioic acid. See, there are synthetic polymers which are synthesized by man. I am just summarizing what we have studied so far because of some students coming late to the stream. So synthetic polymers are those which are manufactured by man, They are not, they do not occur naturally, and they are classified into two classes: condensation polymers and addition polymers. Condensation polymers are the polymers formed by the condensation reaction, in which small molecules are produced during the reaction, like water and HCl. Now they can be, condensation polymers can be studied under two classes. One of them are polyesters and the other ones are polyamides. Now we are currently studying polyesters. One of the polyesters is the terylene. What are polyesters? Polyesters are those polymers in which monomers are combined to each other with ester linkage. The ester linkage holds the monomers together in the polymer chain. So terylene is one of them, and terylene is formed by the combination of two different types of monomers. One of them is benzene 1,4-dioic acid, the other one is ethane 1,2-diol, and the reaction proceeds at 280 degrees C, and the catalyst is antimony 3 oxide Sb2O3. Now this is a condensation reaction, and during condensation reaction small molecules have to be removed, and those small molecules could be water in this case. Now in this case, this ethane 1,2-diol, the alcohol group from this diol will lose its hydrogen from each side because a polymer is being formed. Now the carboxylic acid group of this dioic acid will lose its OH group from each side. These H groups and OH groups will combine with each other to form H2O. So the small molecule water has been produced as a byproduct. Now let us see what are the remaining parts of these two molecules. The remaining part from the dioic acid is like this. And the remaining part from this diol is like this. Now this carbon atom has one vacant valency and this oxygen atom has one vacant valency. So they will form a bond with each other, and this carbon atom too will form another bond with an oxygen atom from the diol placed behind this. So this reaction will be continued on this side, and this oxygen atom will form another bond with the carbon atom in front of it, which would be coming from another dioic acid. So this would be continued on the other side too, and this would be continued for n number of times. Now if you look at this linkage type, C double bond O, single bond O, single bond C, this is ester linkage. This is the functional group of esters. And this continuation sign on both sides mean that this type of chain is continued on both sides for n number of times. That n number could be any large number, like there could be 100 monomers, 1000 monomers, or even millions of monomers in one long chain. And this structure of terylene that I have drawn is one repeat unit. This is terylene one repeat unit. Although the part I have shown in this part of the polymer, this part is coming from two monomers, but still this is one repeat unit. Why is that? Because monomers are different from each other. If monomers were exactly the same as each other, then this would have been two repeat units. But in this case, there are two different monomers being used, so the part coming from two different monomers in the polymer chain is one repeat unit. And in this case, the water molecules would be water molecules produced would be 2n. Why is that? Because if n number of this and n number of this are being produced, so they both have two functional groups. That would form two water molecules from one set of molecules of monomers. That means if there are n number of diols and n number of dioic acids, the water molecules produced would be 2n. The next polyester in our syllabus is polylactic acid, or simply PLA. Now, in order to construct the structure of this polylactic acid, we first need to know the structure of lactic acid. See, lactic acid is the common name of the acid. The chemical name of that acid is 2-hydroxy propanoic acid. That means the displayed formula of lactic acid is like this. This is the structure, this is the displayed formula of lactic acid. Now, when this lactic acid undergoes polymerization, see, first of all, how does it undergo polymerization? We need specific conditions for that, and the conditions are that we need to heat it in the presence of concentrated sulfuric acid. Concentrated sulfuric acid works as a dehydrating agent, and it removes water molecules. And as water molecules are being produced, the reaction becomes a condensation reaction. So now when this starts undergoing polymerization, these atoms are arranged in this way. Now, if there are n number of such molecules, this is lactic acid. Now, this monomer has two different functional groups in it. One of them is an alcohol group and the other one is a carboxylic acid group. Now, the alcohol group will lose its hydrogen and the carboxylic acid group will lose its OH group, and that H and OH will combine together to form H2O. Now, if these are n number of molecules, that means this bond has been broken. And this carbon atom has one bond vacant. It will form a bond with an oxygen next to it, this type of oxygen coming from the same structure. It will form a bond with that and will continue to proceed on this side, and this oxygen will form a bond with a carbon like this, which will be coming from another structure right behind it, and this will be continued for n number of times. So this is one repeat unit of polylactic acid. If I had to draw two repeat units of polylactic acid, it would have been like this. See, these are 2 repeat units of polylactic acid. Again, if you try to identify this bond type, this linkage is ester linkage. That means polylactic acid too is a polyester. And guys, I need to remind you another very important thing about this syllabus, that your fingers won't hurt if you press the like button. So please. Okay guys, so now I'm moving on to the second type of condensation polymers, and they are polyamides. And polyamides are those condensation polymers in which the monomers are bonded to each other by amide linkage. Now again we have to study 2 different polyamides. One of them is nylon. And nylons are actually of different types. There are different nylons. The most common type of nylon is called nylon 6. Now nylons, there are 2 different ways to produce nylons. One is by the reaction of a diamine to a dioic acid. That is the traditional way. That way has been followed for many years by scientists to produce nylons. Nylon was produced by that way, but later on we discovered another way which was more effective, which was cheaper, and which was more efficient and quicker way of producing nylon. I'll come to that later. First, let us take a look at the traditional way. Okay, so there are, for the old way, even the old traditional way, it has two possible sets of monomers as reagents. One of the monomer has to be 1,6-diaminohexane, but the other monomer could either be hexane dioic acid or hexane dioyl chloride. It could either have two functional groups of carboxylic acids or it could have two functional groups of acyl chlorides. We could use either of them. See, but the difference between them is that if we use hexane dioic acid, that requires heating and that requires a catalyst which is concentrated sulfuric acid. But if we use a dioyl chloride, like hexane dioyl chloride, that does not require heating and that does not require any catalyst. It would proceed at a significant rate without any catalyst and at room temperature. But the thing is that this hexane dioic acid, this monomer, is cheaper than hexane dioyl chloride. So overall the cost of the reaction is same, not exactly the same, but still it is comparable to each other. So we could use either of these reagents. For example, if we are using hexane dioic acid, see, this is hexane dioic acid and this is 1,6-diaminohexane. So if we are using this set of reagents, we need concentrated sulfuric acid and we need to heat it. The type of reaction that takes place is condensation. So the amine group will lose its hydrogens from each side and the carboxylic acids will lose their OH groups from each side. Those H and OH groups will combine together to form water, which is the byproduct of this condensation reaction. The remaining part from this molecule would be like this. And the remaining part from the second monomer would be like this. Now this carbon and this nitrogen, they will form a bond with each other and this chain will be continued on both sides for n number of times. If there are n such monomers and n monomers like these dioic acids. So this linkage between the monomers which is holding them together is amide linkage. And this amide linkage will keep on repeating itself several times. This is why this polymer is called a polyamide. And this is called nylon 6 because of each of the monomer have 6 carbon atoms in it. If there were 4 carbon atoms in total in each of the monomers, then this would have been nylon 4. If there was 8 carbon atoms in each of the monomers, then this would have been nylon 8. So actually there are different types of nylons. There are different types of nylon like nylon 4, nylon 5, nylon 6, nylon 8. They are they form different textures of nylons, but the most common one which is used and which is most commonly produced is nylon 6. This is the nylon which is used in the clothes, to make the clothes and dresses, and the thread is this nylon 6. And this structure that I have constructed, the part that I have shown of this polymer is 1 repeat unit. This is nylon 6 is 1 repeat unit. Again, why 1 repeat unit? Although the parts are coming from 2 monomers, but the monomers are different from each other. So this is just 1 repeat unit. This is not 2 repeat units. This reaction can be carried out, as I told you earlier, that a diol chloride could also be used instead of this dioic acid. For example, if we are using this diol chloride, which again contains 6 carbon atoms in total, and there are n number of such monomers, they are reacting with n numbers of 1,2-diaminohexane. This time a condensation reaction will take place between them without using any specific conditions. Like we do not need to heat them, we do not need to use any catalyst. Just directly by mixing these monomers, amine groups will lose their hydrogens, whereas acyl chloride groups will lose their Cls, and those hydrogens and chlorines will link up together to form HCl. I forgot to balance the equation. Please put a 2n behind this water. Similarly, 2NHCl will also be formed in this reaction, and the remaining parts of the molecules will link up with each other and the chains will be continued from both sides. This is again amide linkage. If you look at the structure of this polymer and look at the structure of this polymer, they are exactly the same. That is, they are one repeat unit of nylon 6. Now both of these reactions, this is the old way of manufacturing nylon 6, but later on we discovered another way which was more effective in the manufacture of nylon 6. The new way of making nylon 6 is by using a cyclic compound, and that cyclic compound is called caprolactam. And the type of reaction that takes place is called ring opening polymerization. And the conditions needed to for this reaction to proceed is heating in a nitrogen environment. Now let us take a look at the structure of caprolactam. See, this is the skeletal formula of caprolactam. This is the skeletal formula of caprolactam, and this contains 6 carbon atoms, but they are arranged in the form of a ring, and there is an amide linkage already there. So when we open up this chain by using these conditions, heat in the presence of nitrogen atmosphere, this ring starts opening. This ring opens and forms a straight chain, and many of those straight chains start linking up with each other, and they form a polyamide. In fact, they form nylon 6. See, this is the part coming from one caprolactam molecule when the ring is opened, and this will continue to form bonds with other monomers on this side and on this side. That means the chain would be continued from both sides for n number of times, and the linkage between them is still amide linkage, and there are no byproducts formed actually. This is why it is not called a condensation reaction, it is called a ring opening polymerization reaction. So there are no byproducts formed because they are just formed by the ring opening, but the linkage is the same and the monomer structure is the same, the repeat unit is the same. This is again nylon 6, 1 repeat unit. So this way of production of nylon 6 is more efficient, it is quicker, and it is more cost friendly. So this is, in the recent years, only in the recent years, nylon has been industrially manufactured by this new way. Before that, for many years, the nylon has been manufactured by the previous ways, like by the condensation reaction between dioic acids and diamines, or dioyl chlorides and diamines. Now another polyamide that is in our syllabus is called Kevlar. Okay, now this Kevlar is again produced by a condensation reaction, and there are two different monomers used in this reaction. One of the monomers is benzene 1,4-dioic acid and the other one is benzene 1,4-diamine. The conditions required for this polymerization are heating in the presence of concentrated sulfuric acid catalyst. Again, concentrated sulfuric acid acts as a dehydrating agent. It removes water molecules. Now, how it does that? Let's take a look. See, this is a benzene 1,4-dioic acid, and there would be n number of such molecules. And this is a benzene 1,4-diamine, and there would be n number of such molecules. Again, the reaction will proceed in the presence of concentrated sulfuric acid, and heating would be required. Amine groups will lose their hydrogens from each side, and carboxylic acid groups will lose their OH groups from each side. These H and OH groups will react together to form water, and the remaining parts of the molecule would be like this. Now this carbon atom will form a single bond with the nitrogen in front of it. This nitrogen atom will form another bond with a molecule like this in front of it, and this carbon atom will form a bond with another nitrogen atom from a molecule just like it behind this. So this would be repeated for n number of times. So this is the structure of one repeat unit of Kevlar. Again, this is amide linkage between the monomers, so this is a polyamide. And here better complete this because I need to draw a very large diagram on this entire board, so I will have to erase it to do the next thing. And get your hands ready for that. Alright, so I am erasing it now. Now let us take a look at the at a large structure of Kevlar. For example, suppose this is one long chain of Kevlar, the polyamide, this is one long molecule of Kevlar, a polymer. Now I'll draw another such molecule below this. And I'm drawing another chain. All these chains are continued from both the sides for a very long chain, for the formation of a very long chain. Now these arrange, see, once that condensation reaction that we discussed previously that has taken place, these long chains of polyamides are formed, and these long chains arrange themselves like this, parallel to each other. And why is this parallel arrangement possible? This is possible because of the formation of hydrogen bonds between these groups. This NH group is a highly polar bond. This C double bond O, this group is a highly polar bond. So the hydrogen from NH group will form a hydrogen bond with this oxygen, which is partially negative. This hydrogen is partially positive. Again, a hydrogen bond between this partially positive hydrogen and this partially negative oxygen. So these hydrogen bonds will keep on forming between these groups, and the overall structure of this Kevlar will have many of these hydrogen bonds. Many chains of the Kevlar polymer are arranged together compactly because of these hydrogen bonds. So these hydrogen bonds, these many chains which are already very strong chains, they are arranged compactly with each other due to strong intermolecular forces of attraction known as hydrogen bonds, and there are many hydrogen bonds between each layer. This makes the structure very strong. So Kevlar is an extremely strong structure, and it does not undergo combustion. It is sort of a fireproof material. It does not attract fire to itself, although it is an organic compound, but still it does not get it is not flammable. So this material is used as number one to make bulletproof vests, number two to make fireproof vests, like those which that the fire controlling authorities wear, the special dresses. Those dresses are also made up of Kevlar, and similarly the bulletproof vests are also made by the Kevlar. And this will bring me to the uses of the polymers that we have studied today. I'll give you a few seconds to note this down. Let me know when you have completed this. I'll move on with the uses. Guys, I hope you have copied this. So I am erasing it and moving on to the uses of these condensation polymers. Okay, so terraline, you've already studied the uses of terraline. It is used to make cushions and mattresses. You already know that from your O-level syllabus. Then moving on to PLA, it is used to make the biodegradable plastic. See, I told you, if you are my student for a long time, then I have told you earlier that there are some plastics which are biodegradable. They should be used instead of non-biodegradable plastics. If you are new, I will explain what biodegradable and non-biodegradable means. See, biodegradable materials are those which are decomposed by living organisms, the microorganisms like bacteria and fungi. So those are biodegradable materials, and those which are not decomposed by these microorganisms are non-biodegradable. And use of biodegradable material is always preferable. Why is that? Because non-biodegradable material does not decompose. So after using, when we dispose it off, it remains where we throw it away. It starts occupying land. There are landfill problems because of non-biodegradable plastics, and that leaves us with only one option, and that option is to burn them off. And when we do that, toxic gases are produced and released in the atmosphere, which is not healthy at all. So biodegradable materials are always preferable to use, and most of these condensation polymers are biodegradable. The plastics that can replace other addition polymers which are non-biodegradable, that plastic actually is PLA, polylactic acid. It is considered to be the plastic of the future. Like, this is a biodegradable plastic, and if we manage to obtain different desirable properties from this plastic, it would replace all the addition polymers. And for the addition polymers, I already have a separate video on addition polymers. I will, because most of the addition polymers that you have to deal in your syllabus are common as compared to that of those that you studied in your O-level syllabus. So I will share that video with you personally, and you can watch that video. That has already been uploaded in the channel. So watch that video. But there are a few things extra about addition polymers. So your first task will be to watch that video and make notes of addition polymers, and the new things will be discussed in the next video, the new things from addition polymers. So if you have any questions about condensation polymers, the synthetic polymers that you have studied today, you can ask me now. And yes, it is firefighters. You write firefighters. Guys, if you have any questions about today's lesson, you can ask me now. I'm waiting for your questions. Then I'll wind up the stream. Okay, we have a question that is Kevlar a dense material or not? See, it is a moderate material. It is not as dense as many other polymers, but it is denser than many other polymers too. So its density is a little moderate. It is not very heavy. It is not very light. So it is a pretty suitable material for making the stuff like bulletproof vests and the fireproof dresses. So guys, there are no more questions coming up, so that means you have understood today's lesson. There is a lot of learning stuff included in today's lesson, so I would recommend you to start learning from today, and we will continue with the next lesson from tomorrow. I will let you know the timing of the live stream. So thank you very much. I hope this video was helpful. Keep on watching Infotainment Lounge. Allah Hafiz.